southern Sweden. Deep beneath this Scandinavian landscape lies a monster construction challenge, the Hallandsas project. They've been building these two 5-mile-long tunnels for 15 years. 2 previous attempts were defeated by perhaps the world's toughest drilling and blasting conditions, and by the threats of rock collapse and flooding.
It's not good. We should not have this.
Now there's a new team on the block, using state-of-the-art tunneling techniques. Will this underground crew finally get it right? Or will they make one wrong move that will end this project forever? The coast of southern Sweden. Beneath this scenic landscape lies a 15-year construction nightmare. The Hallandsas Tunnel. The massive engineering project has been going for over 15 years. Started in the early 1990s, 2 previous attempts have ended in failure. And now, a 3rd attempt is running into trouble. The only way to cut through this dangerous rock formation is with the huge high-tech tunnel boring machine. The problem? The TBM is stalled out. Simon Taylor is the man in charge of getting the boring machine back on track.
What I'm down here to do now is to just get a status on the machine. We've been stopped for a few days, so it's interesting to know now what time they're going to start up again, and is there going to be any delays, or can we expect to start this evening?
The TBM is a modern technological marvel. It's enormously powerful. Each cutter disc can exert 250 tons of pressure on the rock face. It can deal with both hard and loose rock. It can also pump out groundwater flooding in at up to 105 gallons per second. But theory and practice are 2 different things. The TBM is halted 1.5 miles from the south end of the tunnel. It's 1,900 feet past the tunnel section drilled during the previous attempts, but it still has nearly 3 miles to go to reach the northern section that they left behind. For Simon Taylor, one of the biggest challenges is to claw back the lost time. Instead, he's now falling further behind.
What time do you think you'll start?
I have no idea.
The TBM is supposed to run 24/7, with 2 crews working 12-hour shifts. Every month, there's supposed to be a 4-day maintenance halt. At the moment, they're stopped 2 out of every 4 weeks. Simon wants the TBM up and running again by the end of the shift. He reaches the control room in time to hear the good news. The running repairs to the TBM are almost complete.
Right now it's 4:30. We should be going again by 7 o'clock. So everything, the last preparations are being made now.
Ahead of schedule, the machine starts up again. The team can continue tunneling into the ridge. For Simon, it's mission accomplished. Or so he thinks. The Hallandsas Ridge is a huge natural wall, blocking Sweden's path to Europe. The existing railway line is well over a century old. With one track, it only allows for 4 trains an hour. The whole Scandinavian rail system has to funnel through this bottleneck. Meanwhile, over 1 million heavy-duty trucks cross the ridge every year. The answer to the rail delays and road pollution is the Hallandsas project. 2 parallel 5-mile-long rail tunnels will expand the capacity here from 4 to 24 trains an hour. They're vital, not just to the Swedish rail network, but to the entire European transport system. The rock conditions here are some of the worst in the world for drilling. There's an unstable mix of hard and loose rock. There are also huge amounts of groundwater.
Move it there.
In 1997, during the second attempt at building the tunnel, the team used a chemical agent which caused local cattle to fall ill. Result? A national scandal that took 7 years and millions of dollars to overcome. The new team is making the third attempt. They have 5 years until completion, but they're already 4 months behind schedule and slipping. They're supposed to advance an average of 33 feet every 24 hours, but they're not making it, and the rock conditions are getting harder. They haven't even reached the most dangerous section of the Hallandsas Ridge, the notorious Molarback Zone. This is over a 980-foot section at the northern end of the tunnel route. Crumbling rock and cascading groundwater make it a death trap for the tunnelers. They're mounting a two-sided assault. To the south, they're tunneling, while to the north, they're freezing the rock and then blasting it out. All in a massive effort to break through the ridge once and for all. Back at the TBM control room, alarms sound.
Now the cutter head is stopped. Cable drum. Okay. Sorry. Hello?
The TBM has seized up again.
Yeah, okay.
The cutter teeth will need replacing.
Electrician, Johan. Johan, electrician in the cab. Electrician in the cab.
Deep in the tunnel, the boring machine hasn't moved a centimeter. The head mounts over 70 separate cutter discs, and each is made of a steel tungsten alloy. Costing over $66 million, this is a piece of hardware that you don't want lying around. TBM engineer Peter Gray comes down to investigate the problem.
The cutter heads are the essential bit of mining. The cutter head design, the location of the cutter heads is all critical. And without that, you will have no production. In some ways, it's similar to having teeth in your mouth. If you've got teeth, you can cut and you can chew. Without teeth, there's no way. That's how important they are.
The cutter head has to be slowly rotated to allow the team to reach the faulty disc. Because of the intense heat, cramped conditions, and the weight of the cutter discs, working around the main cutter head is an uncomfortable and dangerous place to be, even when the TBM's not running. As the cutter discs are put under extraordinary pressure, when the machine's working, they don't come off easily. The difficulty of the conditions has taken the TBM crews by surprise. The discs need repairing far more often than planned. The solution is in the hands of Keith, the mechanic in charge of fixing the problems.
I'm under a lot of pressure. Cutters need to be repaired very quickly, and they need to go out and they need to go back onto the TBM. It's a constant process all the time, yeah.
As they grind away at the rock, the pressure on the discs distorts and mangles them. If Keith can't fasten on a new tungsten carbide cutting ring in time, the TBM could come to a grinding halt. Back at the tunnel boring machine, they're removing another damaged cutter disc. Each disc weighs over 330 pounds. In the claustrophobic and dark space, it's hard to maneuver each piece.
Now it's flat on one face and it's too far to measure the depth of the well. And it's too far gone now.
The cutter discs cost nearly $2,000 each. When one is damaged, you can't just throw it away and buy a new one. This disc has been holding up the TBM, but it's too far gone for Keith to lift off the cutting ring. He has to heat the disc in order to fix it, while the clock is ticking.
So, that's it. That's complete. Job well done, yeah?
The TBM delay has cost the construction contractors roughly $500,000. The team remains confident it can deal with the water levels, but they're anxious to press on.
Do you want to go in there and have a look at the end?
There's one section that's become notorious, the Moellerback Zone. The MBZ, as they call it, is a treat for the tunnelers. A mile and a half ahead of them, the zone is a 980-foot section with extremely high water levels and lethally unstable rock. It's by far the worst geological seam within the entire ridge. In its present form, the rock is so unstable in the Moellerback Zone that if the TBM broke through, there's a high chance it would trigger a tunnel collapse, burying the machine and the men on board. The Moellerback Zone is currently undrillable. The Hallandsas crew thinks that they found the answer. To stabilize the rock, they're using the latest, most advanced techniques. At a cost of over $47 million, the construction team are freezing the rock.
How long have you been ventilating now?
Because I've been around for 3 hours.
How much more do you think, Hans?
1 hour more.
1 hour more.
To freeze the rock, the construction crew drills narrow pipes into the face and pumps in a brine solution at -104 degrees Fahrenheit. This builds up a frozen shell around the pipes. In theory, they can then blast out a pilot tunnel without causing a rock collapse.
We're stabilizing the area by freezing. In a bad rock area, we might have bad rock falling down.
The team has been planning this operation for 2 years. They're now making final preparations for an explosion. As each section of rock is stabilized by freezing, the team carefully blasts out another 6 feet, excavating a pilot tunnel which will mark the TBM's route through the frozen mass of rock.
Now we're very close to the Moellerback Zone, so it's very exciting. We're looking forward to go through it. I think by now, working with it for 2 years, we're getting very curious on what's in there.
Back at the cutter head, the race is on to get new discs back in place on the TBM cutter head. The front end of the TBM is a cramped and dangerous environment at the best of times. If you're maneuvering a 330-pound lump of steel, things get even harder. With the cutter discs replaced, they can finally get the TBM going again.
Yeah, we think the problem is solved now. The cuts have changed, and the men are doing a good job. You know, proud of them.
When it's mining, temperatures on the TBM can soar up to 85 degrees Fahrenheit. The machine rattles violently. For the crew, it's like working through an earthquake. Under almost 13 atmospheres of pressure, the 70-plus cutter discs eat through the rock as the machine produces heart-pounding vibrations. Once the cutter discs have done their job, the excavated material is blasted down a high-speed conveyor belt. This conveyor belt not only runs the entire 720-foot span of the TBM, but continues the 1.5-mile journey towards the tunnel entrance, out of the construction site, ending up in a yard over 2 miles from the face of the ridge. A further 60 million tons of rubble will have to pass through this conveyor system before the tunnel is completed. In the Moellerback zone, the rock temperature has been lowered. The team is now drilling precision probe holes. These will be loaded with high-powered charges of explosives to blast through the zone. This drill and blast method is a tried and tested tunneling technique. If the freezing operation hasn't worked properly, then the Hallandsas Ridge could come crashing down on top of them.
We blast towards the center of the tunnel. So the blasting will start off in the middle and then it will work its way out. And you'll notice when we do the blast, it will be not one big bang, but it will be an ongoing bang.
The frozen rock has withstood the pressure of the probe drilling, but the real test will come from the dynamite. If their new technique doesn't work properly, then the explosives they set off could end this project for a third and final time.
There's always a danger involved. We're working with dynamite.
The Hallandsas project is already nearly a decade behind its original schedule.
Electrician.
We've been stopped for a few days.
They're preparing to blast the notorious Moellerback zone. Meanwhile, Kieran Deasy is getting the middle chamber ready for the arrival of the TBM. And his time is running short.
Time is money.
The Hallandsas Tunnel project has been going for over 15 years. Started in the early 1990s, 2 previous attempts have ended in failure.
It's too far in.
Electrician.
We've been stopped for a few days.
Oh boy.
After massive costs and delays, plus an environmental scandal, the project's become notorious. It's into its 3rd attempt, and the team is looking to overcome the Hallandsas Ridge by drilling through from one end and blasting at the other. Given the risk of rock collapses, the team constructs the tunnel lining behind them as they drill, putting in place massive 12-ton concrete segments. The lining is made up of rings of 8 concrete segments. All have to be transported to the TBM on a high-powered train. Then each piece is loaded onto a robotic heavy lift machine, ready to be fixed into position. Precision is the name of the game. To ensure complete accuracy, the segments are maneuvered into position with a military-style laser guidance system skillfully operated by the best the tunnel world has to offer.
Oh, you've got to be careful. I mean, each segment's 12 tons, so you don't want to be hitting anything and them sliding down in the damage or, worst case, kill someone, so...
Once the tunnel is complete, these rings will prevent flooding from the dangerous groundwater within the ridge.
Tell me when it's contact.
These construction workers have the lives of millions of future passengers in their hands. They have no room for error.
Okay, folks. Measure it again when the plan's gone, all right? It's too far in. Yeah. How's that, John? Yeah? Okay.
The shift is a success. They've hit their target. But with over 38,000 segments still to be put in place, it's going to be a long time before these guys will see the light at the end of the tunnel.
it's a long tunnel. It's a few years' work here anyway, so.
Maureen Johnson is the site manager at the precast factory 15 miles away.
We want perfect segments, high quality, made in the right way.
She's worked as a concrete engineer on major construction projects for 30 years. She's now responsible for overseeing the manufacture of the concrete segments that will make up the Hallandsas Tunnel lining.
They have to be very precise on tolerances, so it takes a little while to get that sorted out in the beginning.
Since 2005, the factory has produced almost 10,000 segments at a rate of 32 per day. With the TBM at least 4 months behind schedule, Maureen is beginning to worry about storing the segments outside in the brutal Scandinavian winter.
The winter period here runs from mid to late October, almost to April. Last winter, there was snow on the ground continuously from Christmas Day through to first week in April. That's a long winter, and you have to think about the conditions and how you deal with them.
Before the tunnel is completed, they'll have to manufacture 41,000 of these segments here at a cost of $3,000 apiece. Each one will be hand-finished by some of the world's most skilled concrete workers. The last thing Maureen wants is for all their work to be ruined by the ice and snow.
In the situation we are in at the moment, they might be stacked for 3 months. You get water in the wood, and that freezes and thaws, and that can also be a difficulty.
Back in the tunnel, the TBM grinds on 24/7, hitting its maximum speed of 12 miles per hour. They're so nervous about the water levels they're seeing.
It's not good. You should not have this.
That at every other shift, they're probe drilling the rock face ahead. 164 precision drills act as a reconnaissance device. Flooding is a huge risk, not just for the project, but for the men working on it. Even on the drier sections of Hallandsas, over a gallon per second of water flows into the cutter head. But at any moment, it can suddenly flood up to 53 gallons per second.
One of the reasons that we do this is because of the water, is to try to locate the water and try and prevent the water coming into the tunnel.
For the Hallandsas crew, it's a bone-shaking shift. The probe drilling makes the TBM shake violently, creating a deafening noise. The TBM's currently near the southern end of the tunnel, struggling at a maximum speed of 39 feet an hour through the difficult rock conditions.
This hole appears to be quite dry, and that's good news. What is good for the TBM is good for the tunnel, and it's good for progress.
In the Molerback zone, they're ready to blast.
We want to excavate a nice pile of rock, not a rock that is spread out over 60 meters.
To reduce the shockwave from the explosion, they use a blast shield. The blast will be controlled and should only take out 6 feet of rock, but the risk is always there. When the crew sets off 220 pounds of explosives here, 2 years of careful planning could come crashing down on their heads.
It's too early to say if it was a successful blast, but the sound was good. You could hear a long rumble.
Back at the Molerback zone, the explosion has released poisonous fumes, according to on-site monitoring equipment. When you're underground, these pose a serious threat.
Now we have to move out. Okay.
The team is only halfway through the shift, but it has to evacuate the tunnel until the site can be made safe. They don't yet know if the blast was a success. With mounting problems on the project, the team has called in their ace troubleshooter for an emergency meeting. Alistair Biggert is one of the world's top tunneling engineers. He's been building tunnels for over 50 years. He's seen it all before.
I think the whole project is feeling the pressure. It's well behind schedule. I'm not quite sure to what extent, but probably 9 months behind schedule, and we need to try our best to pick some of that up. If you're a tunneler, you've also got to be an optimist. So I'm a born optimist, and I've learned to be an optimist about tunneling.
Alistair is now making his inspection. As a veteran of over 40 tunneling projects around the world, he has a keen eye for problems. Before he even reaches the TBM, he notices a big problem half a mile into the tunnel.
Alistair, are you concerned about this level of water here?
Yes, I am, actually. They will have to seal it as soon as they can, because this is just bringing in more water. They'll have to come back and grout it.
The rising water levels, which ended the 2 previous attempts on Hallandsas, may be drowning a third.
Water is the great enemy of tunnelers, and we have to have a way of controlling it.
It's not long before Alistair discovers another problem.
Oh boy, oh, there's a lot, isn't there? It's muck that shouldn't be there. It is overflowing from the belts. So they've got to try and control that. You see these wheels here? This trailing gear is running on those wheels. So the muck's got to stay below that level or it unbalances it all.
A fresh eye is always helpful. In less than a day on site, Alistair emphasizes some key points. To start with, the team have to clean out the muck that's clogging up the machine. After the inspection, Alistair meets Simon Taylor and shift manager Peter Gray to discuss the problems he's seen, including the dangerous water levels.
The situation here yesterday anyway was that the total flow is around about 18 litres per second. Which is...
This is coming from behind?
Both.
Yeah.
Before the vacation, that figure was around about 30. But that is obviously still too much.
It's probably over-optimistic to think we'll ever reduce washout to zero.
This is it.
Frankly. I mean, after all, 3 or 4 years ago, this was one of the bigger problems we were discussing, wasn't it? Whether we could get that down to a reasonable figure.
Over a mile ahead of the tunnel boring machine, before it reaches the Molerbeck zone, there's a section of the construction site which is vital to the success of the tunnel, the middle chamber. At just 35 years old, young gun Irishman Kieran Deasy is responsible for this crucial part of the project.
At the moment now, we're probably right on the top of the Hallandsas Ridge, and we are coming down to right in between north and south. So we're probably at the midpoint of the tunnel.
This middle chamber will act as a maintenance area for the TBM when it eventually passes through here. The entrance to this chamber, over 600 feet below the ridge, is only possible through a temporary access tunnel built during earlier construction attempts. The TBM's still over a mile away, but Kieran has to prepare the middle chamber for its arrival. He has to drain the water and stabilize the walls.
2 kilometers behind that wall is the TBM. So the TBM is on its way here. And then we will use this chamber as a maintenance area. So once the TBM comes in, then they have full access of the head to do any repairs, change cutters, whatever maintenance work needs to be done, before it carries on the additional 2.5 kilometers to the north.
The TBM continues to make progress towards the middle chamber. Just when they're getting back on track, work must stop for the health and safety inspector. Back in the tunnel, the health and safety inspector simulates a fire.
We will have a fire exercise with smoke generators and then the fire drill to get the people in a safe place. We will also call the fire brigade and an ambulance because we are pretending some people are injured and that we cannot control the fire. It has to be done according to the law, according to the safety. It's time to start now.
Working beneath the Hallandsas Ridge is a high-risk occupation. Drills like this are potentially life-saving exercises. The TBM crew are ushered into a brand new rescue chamber. But after all the recent delays, and just as the TBM crews are starting to make progress again, a safety drill is the last thing they want.
So the scenario is that we have a fire in the transformers. The field has called rescue service. And the two persons that are suffering from severe smoke injuries, what you will do here now, you will appoint someone who will manage the chamber.
Working on a tight schedule, Kieran in the middle chamber has heavy pressure resting on his young shoulders. The TBM won't be here for a while, but there's a big schedule of work planned, and he has to use his resources as efficiently as he can. One major task is to stabilize the rock through a process called shotcreting. Kieran's under the gun to get the first stage of the job done by the end of the shift.
And here what we have is we have a shotcrete robot, and we just feed the shotcrete into the robot, and in the robot you have a pump with compressed air, and then we pump the shotcrete through the robot out through the nozzle, and there you have a robotic arm so you can direct the shotcrete as you want it. It's a machine gun full of concrete.
As soon as the shotcreting begins, there's a problem.
What's the problem?
The pump is not.
The pump?
The hydraulic pump, which projects the shotcrete from the machine at over 93 miles per hour, has broken down.
Small problem with the pump.
And work has hardly begun.
With this machine we've had standing for the last few months. We haven't been doing much shotcreting, so we've just taken it out this morning now and started to use it, but they'll fix it.
The problem could be more serious than Kieran first thought. With the clock ticking, he's called for help. After 3 hours in the rescue chamber, the TBM crew needs some emergency oxygen. The supply is piped in from the outside. For Anders, his role as safety officer makes him an unpopular guy.
Me's in production and they've been waiting to get going, and then we have an exercise, so of course they get frustrated of this. Because number one is of course to build a tunnel, but it should be done under safe conditions.
During an emergency, this new rescue chamber should power itself out of the tunnel. It's never been tried before.
We are not going to move. Yes. They asked us to move. Yes. You move. Mark this one. I'm going. Yeah. The guy just have to move. You have to disconnect it. Nobody knows to drive it. But you know. No. I'm very close to going. I don't know. Who knows then? Nobody. He's afraid of driving it, so we have to get the rescue service all the way in.
Tired of waiting in the chamber, one of the TBM crew decides to take matters into his own hands. Unfortunately, the oxygen line is still connected. The rescue chamber continues on its own momentum, just 16 feet down the track. Then there's another problem. It derails itself. It's a health and safety exercise showing they need a few more drills. Back at the safety exercise, the workers in the escape chamber are still derailed. Finally, 6 hours after the start of the exercise, the chamber is back on track, even if the door is still open.
When he finally decided that he wanted to drive, it was a happy ending to the exercise. He came down the ramp, and for some reason he wants to go all the way out once it's moving, and I don't have the means to stop him, so we have all the firefighters. Since they have come in now, I will take them for a tour.
The emergency vehicle had to be moved out of the way. Otherwise, it would have held up work on the tunnel.
I think the main production worry was if it got stuck on the ramp, we could not bring in material. And it's also very difficult to move it upwards again. And that was probably why he took it all the way out. So now it's clear to bring in more segments.
In the middle chamber, Kieran's still waiting.
We've had to call for the mechanics to come down because we did a test run before breakfast and everything was working okay, but now we can't seem to get it running, so we've called the workshop in.
The delay is frustrating, but on Hallandsas, delay is the name of the game.
If the mechanics don't come in time, we could lose 6 cubic meters of concrete.
At the Molerback zone, they still haven't had the all clear. With the gas levels too high, they don't know when they're going to get back in to see if the blast was a success. Meanwhile, in the middle chamber, Kieran's 3 hours behind schedule, and the concrete is starting to set. For Kieran, the pressure's on. The Hallandsas Tunnel project has been a construction nightmare for over 15 years. Started in the early 90s, 2 previous attempts have ended in failure.
It's too far in.
Electrician, we've been stopped for a few days.
It's not good.
Now, into the 3rd attempt, this tunnel crew is trying to tackle the project's toughest challenges.
It's too early to say if it was a successful blast. Can we go in or not?
With the safety go-ahead at the Molerback zone, the team is re-entering the tunnel to check the effects of the blast.
We've been waiting for the fumes to come out. That's done, and now we're excavating out. So you see the excavator moving up and down the tunnel, taking out the rock that we have blasted. But remember that we have frozen the rock, so it's minus 15 degrees cold rock. We're bringing it out in a very humid area, and then you see the condense coming off the rock.
The blast was successful. It looks like freezing the rock is going to solve the problem of the zone. Kieran Deasy's trying to shotcrete the middle chamber to prepare it for the arrival of the TBM. But his concrete machine gun has seized up, and he may lose a whole batch of shotcrete worth thousands of dollars.
You're always under the hammer, always under the gun. You're always shooting for a time. Schedules, times.
Kieran's already had plenty of experience of the high pressures of big construction.
Your life just runs away from you because you're always looking forward at a date. And then when you reach that date, there's a new date to reach. So.
After a 6-hour delay, Kieran learns the shotcrete machine can't be fixed. The concrete batch has been ruined and everyone is sent home. For Kieran, it hasn't been a good day.
We've lost a day for shotcreting, so that means we'll have to maybe drag on one more day extra next week. So the schedule now seems to be getting tight.
But it's a small setback in a bigger battle. At the Moellerback zone, this tunneling crew is finally confident they can overcome the biggest obstacle to the success of the whole project.
All the planning that we have done and all the effort that we put into it seems to have worked out well.
Another day, another dollar.
The progress at the Moellerback zone is a huge morale boost for the entire construction team. Neither of the previous 2 attempts got this far.
Looking forward to tonight. Go home and have a few beers.
After a 4-day delay costing tens of thousands of dollars, Kieran's shotcreting is finally underway.
It's a relief now this morning to get everything working again.
The team is now powering forward, shotcreting the chamber as they prepare for the arrival of the tunnel boring machine.
We should be finished up here now 2 or 3 hours, and then we're back on schedule again. We'll be ready for the TBM.
The third time could be a charm at the Hallandsas Tunnel, but they still have 60,000 tons of rubble to excavate.